Okay, so before we get to the idea that we're going to learn for today, I'm just going to remind you of something that we learned right before spring break. We called this basically matrix A, called this matrix X, and called that matrix B. And we used the inverse of matrix A and multiplied that on both sides. The inverse of A to come up with a solution for that. So remember, I can just use the inverse button. So I've got that in the calculator, quit, and then I can use matrix A, which is what I've called it, and hit the inverse key right there, and it'll give me the inverse of that matrix. So if I multiply matrix inverse negative 1.75, 6.25, 0.075 there, and negative 0.125 times the matrix 1.3 and 49, then I end up with the solution that X, the matrix X, is equal to 1.4 and 2.0. And that gives me the variables for X and Y. So X would be 1.4 and Y would be 2.0. Okay, so you need to remember the inverse matrix function in order to deal with our topic for today. And our topic for today is called the Leontief input output model. And it's basically a business model. So that means that we're going to have to look at it in terms of what does it do for us. It's called a production model, which means that it's requiring you to make something. And one of the best examples that they use in several of the videos, and I'm just going to use it too because it makes sense, is the idea of producing, say, like my brother-in-law works at an aluminum plant. So the production of aluminum. So it talks about how much does it take to produce the aluminum and how much do you need to make in order to satisfy the need of the public to produce that aluminum. Okay, so we have a couple of things going on. Then we have what we call the total demand, which is what we need to find out, or sometimes what we know we have to have. So that would be basically put in some sort of matrix. We're just going to call it X. Okay. Now, what we know about making aluminum is that it takes us things like electricity and manpower. It takes some sort of metal kind of thing to put it together, but then it also might take some aluminum that it actually produced to produce the amount of aluminum that we need. For example, it's going to need machinery, and that machinery may very well be made out of the aluminum that they produced. So it's going to take a certain amount of the item that you're producing to actually put back into the plant to produce what you need to get to the consumer. Okay, so there is what we call an internal demand. And that's going to be put in the form of a matrix. And that internal demand is going to be called A as a matrix. Okay. And then the last thing that we really need to talk about is, well, if the total demand comes from what everybody needs in terms of aluminum, we have an internal demand, so the plant that's producing the aluminum has to actually use some of its own product to make more. And then we have what we call the consumer demand. And they call that D. All right, so using that idea then, we know that if we were to take and find the total production, which would be X, and we were to subtract the demand from the consumer, then we'd end up with what the internal demand was. But this internal demand is going to be based on how much you need to make. So that's going to be I times times X. So we end up with an equation that's got two variables for X in it. So the demand that we're going to be able to give the consumer is actually going to be based on the total production minus the amount that it takes to produce that actual amount. Okay. If we solve this out a little bit, you see that we come up with, take an X out of there, and we end up with the identity matrix minus A is equal to the demand. And remembering what we used up here, in order to solve a matrix equation and get the matrix A to move over to this side, we had to use its inverse. So I'm going to need to get this matrix on the other side, so I need to use its inverse. So X is equal to the inverse of that matrix times the consumer demand matrix. All right, let's actually work one then and see if we can't see what's going on there. I picked out question number 217, page 217, question number 19, for us to just look at and actually work through. So it says on the problem number 19, it says that this company's digital division, plastic division, for each dollar's worth of plastics it produces, the plastic division uses some of its own plastic. So this plastic division is using some of its own plastic, 0.1. And then it uses 20 cents worth of electricity. So in order to produce a dollar's worth of plastic, I have to use some of the plastic and I have to use some electricity. The next sentence on down says, for each dollar's worth of electronics produced in the electronics division, they need to use 40 cents worth of plastic and 20 cents worth of electronics. Okay, so a dollar of this means that I have to actually use some of it to produce it, but I also have to use some electricity to produce it. A dollar's worth of electricity is produced by using some plastic and also using some of its own electricity. So some of the electricity that I'm using is going back into the production process. So here's what we call A, or our internal demand, is this matrix right here. There's our internal demand. So it says on question 19, part A, write out the input and output matrix of this particular problem. So here it is. This is the answer for part A of the problem. Okay. Then the next thing that it says 1 month they want to produce $25 worth of plastic and $32 worth of electronics. It says find the value of plastic that the electronics used internally, which is an internal demand. So we know for the internal demand that I need to take A times my demand matrix. So that would be A times the demand matrix here, which would be for an internal demand. So if I multiplied my matrix for A times the 25 and 32, then it says that I need 15.3 parts of plastic and I need 11.4 parts of electricity to just meet whatever it is that I'm asking for internally. Internally, to make this much, I have to have this much stuff. Okay, that's part B then. And part C says, okay, let's find out if I needed to make $36 million worth of plastic and $44 million worth of electronics and meet up with the consumer demand for producing that item. Again, I'm going to produce some of it internally to actually be used in the process. And then I have to meet the customer demand or the consumer demand, which is 36 and 44. So I go back to my idea of the Leontief input-output method and use the identity matrix minus A and its inverse times the consumer demand to end up with the total demand. So I went ahead and did that. Here's my I minus A. Well, this was A. I took my identity matrix, which is 1, 0, 0, 1, and I subtracted them and I ended up with this matrix. Take the inverse of that. Well, here's the inverse of this matrix. You can look on your calculator for that. Multiply the inverse of that times the consumer demand matrix and end up with our total demand matrix, which means that I have to produce $72.5 million worth of plastic components and $73.125 million worth of electricity components to make sure that I can take care of what the consumer wants, along with taking care of whatever I used in the process of making all that much. So the consumer gets theirs, and the company gets to put back into the company what it needs, as long as we produce this much of the product. There are several videos out here. Please replay this as many times as you need to. Take the time to sit down each one and figure out which one is the matrix for X, which one is the matrix for A, and which one is the matrix for D. Be careful how you set them up. This is for every $1 worth of plastic, I need this kind of an amount. For every $1 worth of electricity, I need this kind of amount. Because when I multiply, I need those to be, remember that whole process of multiplying left, right, up, down. I need it to multiply out so that these match with that. So be careful how you set up this matrix. Make sure that the numbers are in the right spots. And I hope this helps. We may need to have a Zoom meeting on this, so let me know when you get to the end if you need some help with it.